Hi friends, my name is Narasimha and I'm studying my BTech in Institute of Aeronautical Engineering College. Today, as a part of my AAT Tech Talk videos, I want to explain a topic in my subject, that is image processing and analysis. In our day-to-day life, in every aspect in our practical life, such as scanning a QR code, Google Pay, Phone Pay, or seeing any image in our mobile, everything is dependent on image processing. So today my topic is also related to it, and my topic name is interacting with large 3D datasets on a mobile device. First of all, I want to say an example, that is, if we are seeing a website in a laptop and same website is having been viewed in a mobile phone, both it is showing in a same manner, means up and downs are not there, and the website the page is showing in the same manner, then we call such web page is known as responsive. Means in both the ways they are showing in a same manner. That is, here image processing has been used. So in the same way, in a mobile device, how we can view large 3D datasets is my topic. So we'll have a look at it. Introduction. Visualizing 3D datasets requires a high level of GPU performance due to the computational demands of volume rendering algorithms. In the past, the GPU hardware found on mobile device was too underpowered for high resolution datasets. That is in the length of 512 length and 512 breadth and 512 and next and higher. Rendering algorithms that produce a higher quality images such as raycast volume rendering and put even more pressure on the both devices to accommodate these performances shortcomings. Much of the previous work has been done with client server based implementations. Although powerful, these applications require a reliable network of sufficient bandwidth to perform interactively. So first of all, what is a GPU? GPU means graphics processing. So in olden days, this graphics processing is not that much advanced and that much in a performer manner. So nowadays it is being advanced and it is being used in a high level manner. So this is in this slide, I want to explain that. In the first line, you can observe that in the past, the GPU graphics processing unit hardware found on the mobile device was too underpowered, means that much useful manner. Although powerful, these applications require a reliable network of sufficient bandwidth to perform interactively. To avoid the additional complexities that a network introduces, we focus on local implementations, rendering done on the device itself. Such applications typically use 2D, means two-dimensional texture-based algorithms, lower sample rates, and lower resolution volumes. These methods have resulted in frames rates of up to 7 frames per second. So when we take, for example, when we have a picture, and it can any picture maximum it contains 256 frames, means 0 to 225, from 0 to it contains to 2 to 255. So 256 frames are contained in every picture. For example, the black and white picture has been nowadays converting into color picture in the phone itself, in the apps, etc. This all are using image processing technique, and they are using matrix operations, and they're changing the pixel size and the frames to be fit at that second, at that moment. So by that only the brightness, highing of the brightness or lowering of the brightness has been also being done. However, they produce lower quality images compared with desktop implementations. Additionally, resolution and downsizing in a professional setting is frowned upon due to the data under representation. Today, graphics hardware in mobile devices has become more powerful, allowing rendering algorithms to produce higher quality images more quickly. So, for example, some of the datasets in the laptop we can visualize very clearly, but in the phone mobile device, that much clarity will be missed. This due to is the image processing technique and the frames per second. These are only up to 7 frames per second. Finding the appropriate 3D texture size. One of the main reasons that ray casting has been a rarity in mobile devices was not only due to the lack of GPU power, graphics processing unit power, but that most devices up until recently didn't have 3D texture support. Fortunately, the Shield tablet does have this support. One influence on the raycast algorithm per performance is the size of the 3D texture. Sorry, this is for the inconvenience. 3D texture. For this project, we use a 5x12 scan of a dog's head. This dataset was provided by Sarah Nemok of the Oregon State University College of Veterinary Medicine. It produces a good example because it is a representative use case within the field of veterinary medicine. So here, visualization viewpoints. Here we can see two images. This first image, example slices from the dog's head dataset. This scan is a representative use case within the field of veterinary medicine. So this is an example of dog set data set. So we are all in need of data set, that is Irish data set or air quality data set, air passengers data set, etc. All the columns and the data points, mean the rows are relationships between the rows and the columns are given by the example of numericals. Different types of numericals can be seen in the data set. So when we see the data set in the pictorial method, this is a result. Once have a look. Next, figure 2. Visual artifacts provided by downsizing, means by decreasing the size of an image, we can visualize this. Once have a look. Okay. Next, this is a third image, same dimensional subvolumes. Both images are rendered from with the same number of pixels, but the latter is rendered with native resolution data, which allows for data preservation while keeping interactive frame rates. The only drawback with the lower image is the inability to view the entire data set. So when we are seeing the image in a mobile or in mobile, so we can see some of times the image is very dull or brightness is low or the picture size is not clear. So in that cases, the main reason is the lower image is the inability to view the entire data set. Means I'm giving a practical example. Means where we are taking a photo or when the data set has been loaded in our mobile device, the entire dataset can't be loaded at that speed, which is can be loaded in the laptop or a PC. Next, for testing reasons, we keep the sample rate at 500 steps per frame. In comparison, an iPad 2 raycast implementation achieves a frame rate of 0.8 fps with 80 steps per ray and uses a smaller dataset. Even though there is a significant increase in performance, 4 to 6 fps is not enough. While interacting with the application, whether it is adjusting render variable parameters or rotating the scene, there are noticeable delays between performing a gesture and the application's reaction to it. It is clear that the dataset's resolution is too high for the GPU, graphical processing unit, to handle directly. So we are known as resolution, means the length or size of an image. Yeah, dataset's resolution is too high for the GPU to handle directly. So the next step is to scale the volume down by a factor of 2 in each dimension. Rendering the new volume with the size of 256, 447 increases the rotating frame rate to 17 to 18 fps. Means the speed of an rotation of a frame rate will be increased by reducing the dimensions of the resolution of the dataset. Now that we have a texture size that we know suits the shield tablet, we need to address the challenge of not restoring the to volume downsizing by experimenting with subvolumes. Next, this is an image, figure 4, rendering 8 small 3D textures as one. Given the position of the ray within the geometry, we page into the correct texture and offset accordingly. STP are textures coordinates similar to Cartesian XY set. So here we can see, for example, I will give an practical example. That is, if we have lots of work and if we see that we can't do because by appearing only the size of the work is more. But if we divide the work into so many subparts and individually work on each subpart, and at last by combining all the results of subparts, the whole work can be done in easier manner. So the time complexity will be reduced and the space complexity will be reduced and the mood means the doing interest will be increased by of a user. So in the same way, while we are downloading the large 3D data sets in a 3D large data sets in a mobile device, we have to, the whole frames will be divided into subparts, means a Cartesian. Here we can see the actual box means contains of eight boxes. And if we divide the each box into subparts and in 8 boxes, STP will equally parallelism the XYZ of the Cartesian plane. Next, subvolumes. Instead of using the 256 cross 256 cross 447 downscaled volume, we can extract same dimensioned subvolumes from the original dataset. The effect is as if there is magnifying glass inside the original dataset, allowing the user to view the unaltered full resolution data. Figure 3 shows, once have a look of figure 3. So figure 3 shows how much more detail exists for the number of pixels being rendered. The main drawback of subvolumes is that we aren't able to explore the entire dataset without manually specifying what subvolume to load. So the subvolumes, while which I said before, will subparts of the main dataset, and at last it will combine. So the main drawback means the disadvantage of the subvolumes is we have to specify manually the what the subvolumes to load. Otherwise, it will not work. The grid view. To address the issue of manually loading subvolumes to maneuver within the dataset, we introduce a method that lets the user explore the various subvolumes. Next, the bread slice view. Essentially, we allow the user to flip through the volumes as if it is were and loss of bread. Once an interesting slice has been chosen, tapping the image selects a sub-region of the slice. To help increase the user spatial awareness, we use a highlighted version of the downsized volume as a frame of reference. This not only helps with understanding where the subvolume is located within the entire dataset, but it also helps show the correct selections, context, and the user spatial orientation. Next, conclusion at last. So I think you have got an idea how to do it. Not only does contrasting the texture size benefit the GPUs, means graphical processing units performance, but it also bonds the memory footprint of the volume being rendered. Although we show that the Shield tablet was able to successfully load a 5 by 12 into 5 by 12 into 894 dataset, the voxel representation was only a bit, 8-bit single channel. If the volume used a much higher voxel representation, as in 16-bit RGBA, the memory footprint would have been much higher and the data wouldn't have fit on the device, because Android severely limits the amount of memory for a given application. Our method is designed to account for devices with both performance and memory limitations. So I think you have got an idea how this large 3D datasets on a mobile device will appear. So thank you, friends. I hope my lecture is useful for you. Thanks for watching.